Okay, so this is notes 1.4. Is it a function? So we're going to be learning about functions today and how to figure out if a relation is a function. So we have two learning targets today. We have one, I can determine the domain and range of a given relation. And two, I can determine if a relation is a function. So if you need to pause the video and write those down, do that right now. Okay, so our new vocabulary word for this lesson is going to be relation. And what a relation is it's a set of data points and we also know this is an association. Because what do we know an association is? Something with two variables. So a relation has a set of data, and if it has two variables, it's an association. We have seen data represented in quite a few different ways. So we've seen and created tables. We've made and looked at graphs. Last class, we got to see a mapping. We've definitely used equations. We've also used ordered pairs. And finally, one other way you can represent data is with a verbal description, which we can also call a story. So we have this graph over here, and we know that's one way we can see data, but I want to represent it in three other ways. So an ordered pair is just your XY pair. So if we look at this graph, our first point is 174. Then we have 176. We have 282. We have 381. We have 576. We have 795. We have 988. And we have 1089. So make sure these are the ones you got. Okay, so ordered pairs, we made our ordered pairs. Now we want to make a table. And now that we have our ordered pairs, it's going to be pretty simple to make a table. So we have X on the left side, Y on the right side. I'm just going to take my ordered pairs and write them in. So I have this first one, 174. I have 176, 282, 381, 576, 795, my table's kind of run out of room, 988, and 1089. Okay, so we have a table, we have some ordered pairs, we have a graph. Another way we can represent data is a mapping. So what a mapping is, it's this picture. It's two ovals. We know one is our X and one is our Y. And we write our X values, and we write our Y values that go with it, and later we'll draw arrows to the X value and its appropriate Y value. Now the thing about a mapping is you don't write repeats. So in this table over here, we had two 1s in our X column, and we had two 76s in our Y column. But in a mapping, we're just going to write this one once. So we have 1, 2, 3, 5, 7, 9, and 10. For our Y values, we have 74, 76, 82, 81. We have another 76, but I'm not going to write that because no repeats. So I have 95, 88, and 89. Okay, so this is 4 of those ways that we talked about up here that we can represent data. So to talk about our data, we're going to look at the domain and range. If I'm ever going too fast on these notes, just go ahead and pause it, write down, or you can go back, and then you can catch back up. So the domain is going to be the set of independent values. And what are our independent values? Those are our x values in a relation. So for this set of data, it's going to be all of these x values. Now, domain is the same way as a mapping where we don't repeat. So the way I write domain is I write a brace, and then I write my x values with commas in between. So I wrote only 1, 1 because I don't do repeats. So we have 1, 2, 3, 5, 7, 9, 10, and I close it with a brace. Now if the domain is our set of independent values, the range is going to be the set of dependent values. And our dependent values are going to be the y values in a relation. So same with our range, with a range as the domain, is we're going to do our braces. We're not going to write repeats, and we're going to list out our y values. So we have 74, 76, 82, 81, 95, 88, and 89. Now, if I already have a mapping, that's a great place to be able to write my domain and range from because there are already no repeats. If I have a table or ordered pairs, I just need to remember to not put in repeats. So to help you remember which one is domain and which one is range, we have a little saying called Dr. XY lost his ID. So we have our domain is our x values, is our independent variable or value. We have our range is our y value, and it's also our dependent value or variable. Okay, that's just an easy way to remember it. So our second vocab word for this section is going to be function. And a function is a relation, so it's a type of relation in which none of the first coordinates repeat. So what that means is all of our x values have only one y value. So that means our y values can still have more than one x value. But what it means is we can't repeat an x value. Okay? So by definition, if we look at our example 1, which is right here, is our example 1 a function? And of course, we want to explain why or why not. So if I look up here, I need to see that all of my x values have only one y value. If I look at a mapping, without drawing these lines that we're going to draw later, I'm not going to know whether or not this is a function. I have to wait until we've drawn our lines, and we're going to do that on the next page. So I'm going to look at my table, and I'm going to say, okay, I have 1, 1, oh, I have 2, 2. I have 2 1s. So it is not a function. We're going to say, no, it's not a function because x equal 1 repeats. And remember, it only matters if x's repeat for a function. It's okay to repeat y values. So we had this 76, we had two 76s. It's okay if those repeat. But we know it's not a function because we had 2x equal 1. Okay, go ahead and flip it over to your next page. So we're going to represent this relation shown in this table as 3 other things: set of ordered pair, a graph, and a mapping. So set of ordered pairs, we know the top of our table is x, the bottom is y. So I'm going to start writing my ordered pairs. I have 1, 5, 2, 6, 3, 7, 4, 8, 5, 9, 6, 10, and 10, 14. So now that I have my points, it's going to be easy to graph. I'm going to say 1, 5, 2, 6, 3, 7, 4, 8, 5, 9, 6, 10, and then we have 10, 14. So if you need to pause it and make sure you plot all those points correctly, go ahead and do that. Now let's make our mapping. So I'm going to start with 2 ovals. My first one is x. My second one is y. So like before, I'm going to take my x values and I'm going to put them in the x side. I'm not going to put repeats. So I have 1, 2, 3, 4, 5, 6, and then 10. For y values, I'm going to do the same thing. So I have 5, 6, 7, 8, 9, 10, and then 14. So here's where I said we talk about these arrows. So with the mapping, what we can do is we can draw lines from our x value to our y value. So 1 and 5 go together. 2 and 6 go together. 3 and 7, 4 and 8, 5 and 9, 6 and 10, and 10 and 14. So if I, like on the last problem, if I had 2 1s, I had a 1 that went to the 5, maybe the 1 that went to 6, I would draw 2 lines coming from the 1. But with this one, we only had 1 x value for every y value. So that's looking pretty good. So we want to remember that the domain is all of our x's. The range is all of our y's. So the domain for this problem, we're going to draw that brace. We're going to say 1, 2, 3, 4, 5, 6, 10. So we just wrote down all of our x values. We didn't have any repeats, so we just wrote them all. Range is going to be the same thing. So I'm going to say 5, 6, 7, 8, 9, 10, 14. So as a refresher, a function is when what? No x values repeat. So for this one, this example number 2, is it a function and why or why not? Well, we only had 1 x value for every y value. None of our x's repeated. So yes, we're going to say because none of our x values repeated. Okay, this is the end of this video, but you're going to watch the next video to do the last page of your notes. Remember, you can go back and rewrite things if you need to, or you can go back and pause them to be able to record things faster.